Alright, welcome back to this other tutorial where I'm going to talk about if you're given, if you are given a function like this and you're required to derive something of this kind here, and you're seeing down here, we want to use logic gates in order to represent this. So first, if we look at it in the truth table, x, y, z, all possible values are here, like we said in class. Right, 0 1 0 1 0 1, and then 0 0 1 1 0 0 1 1, and then here it's a simple logic of is it 2 and then 4, something of that kind, and then I think is it 1 and then 2 and then 4, around here, how to derive all these possible values in order not to miss one. So if how did we get this? The f is equal to x plus y, but the negative of y, the negation, which is not y, then times z. So you have x, which is 0 here, and then not y, that is a 1, okay? So you have 0 and then not 1, which is a 1, and then a not 1 times a z, which is a 0. So here in between we have a plus, and here we have a times, okay. So remember, this one tells us or, and then this one tells us and. So the moment we have the and in between 0 and this one will give it a 0, because in and is only true if this is like this. Actually, if this is 1 and this is 1, so you come up with 0 and then or a 0. So the or, if this is 0 and this is 0, the outcome is 0, which is what is there, okay? Yeah, so let's have another example for us to understand very well on this line. For example, how do we get this? Of course, the x is 0, you put it there, and then we have the and this value, which is z, not z, and then not z, sorry, not y, is 0. So if this is 0, then not becomes a 1, and then times, okay, times, I'm following this, times the z, and then the z is 1, so I put here 1. So the moment that this and here, they are all both 1, the result is going to be 1. And then when I bring this one here 0 plus this one, remember I have the O. So if it is, this is 0 and this is 1, in the O it is at least one value. So this is, if this is 1 and this is 0, I'll have a result of 1, okay? So that is why we have a 1 here. Alright, so how do we draw this? Using our logic gates. Of course, from what we said we have x, y, and z, and we want to derive at f, okay? So at first we are seeing that this is a multiplication, and the multiplication is comes faster than the plus. Okay, so we have to multiply the y and the z, and then we add the x. Okay, so we have the y, but the y has a negation on it, so we pass it through what we call the NOT gate. Okay, pass through the NOT gate, and then we pass it through the NOT gate, and then there we get our y, which is a negation when it is here. Okay, then the z is not having a negation, so for it comes direct. So we have this times the z, which is here. Okay, and this is the AND gate, so this is the AND gate. So we pass y and z in the AND gate, so inside here we have this times the z, so it comes out as what comes out here is the y times what? Times z. And then we bring our x, which is this side, it comes as an x still. Then we pass these both, this one and this one, in an OR gate. So this is the OR gate, and then we arrive at our answer, which is F. Okay, which is F. All right, so if you didn't understand it very well, we are going to do some examples, don't worry. Okay, so we have these two questions whereby we have y is equal to the brackets times c. So this is not a plus not b into c. And then we have another one, which is y is equal to not a times b, and then plus not c. Let's see how we are going to answer this. How can we transform them into logic gates? So number one is y is equal to not a plus not b into c. Here I've just put this one here as our guide. The AND, the OR, and then the inverter. Inverter is called the NOT gate, so don't get confused. The NOT gate, we are going to be using this. Alright, so let's write down A, and then we write down B. Okay, and then we write down C. Remember that we have not A. Okay, so if it is not A, we pass it through the NOT gate, which is here. So I'm going to draw here the NOT gate, which is this. Please don't worry about my art. I'm not an artist person, provided you understand. So it means that here I have my NOT A. Okay, so here I have NOT A, and then remember we have NOT B. Okay, so the same thing here. Let's have a NOT B. We pass through something like this for negating it, and then what will come out here is the B, which has a NOT. Okay, all right, so then C, we don't have anything, so for it continues like that. We have the C here. So these two have an AND in the middle. Sorry, they have an O in the middle, which is a plus. So we pass it through the OR gate. Okay, through the OR gate. So the OR gate is right here. So I have to draw the OR gate, which is like that. So the OR gate. So what will come out here from the OR gate, friends, is going to be A, and then plus what? Plus a B. Okay, B naught, the values that I have here. So from there you see that C has nothing, and then C is multiplied by these two. So I have to multiply this. Okay, multiply these two, and then multiplication we said is an AND gate, so which is this. So I'm going to draw an AND gate here. I hope it's looking like this, so an AND gate, and what we shall have there is now the result, which is Y. Okay, so we have Y at the top. Alright, so this is equivalent to our equation, which is up here that we want to write. So this is how you can transform these things, the equations into logic gates. Let's look at the next example. We have Y, which is equal to not A times B plus C, actually not C. So we have our guide, which is there, and as usual let's write A here, and then we write our B around here, and write our C around there. So we want to get Y from here. First of all, we have the not A, so I'm going to negate this with a not gate, which is that. So what I have here is actually A bar. Alright, and then the B is actually not having anything, so I'm not negating this. I still have my B, but these two A and B are actually combined by the AND gate, which is a times. So I'm going to combine these two by the AND gate. The AND gate is here. Okay, so the AND gate is there. I hope it's like this. So what I have out here is the A bar times the B, right? And then my C has a negation on it, so I want to first pass it through a negation on it, which is this. Okay, so what I'm having here as an output is negative C. Also remove this. Okay, so what I have here is a C, which is a negation, and then you're seeing that I get the whole this, which is actually this one, this line here, then all that. So this is a plus, which is the OR gate, which is here. So I'm going to pass this through something like an OR gate, something like an OR gate, which is like this. Okay, which is like that, and then finally here I have the whole equation here, which is the A bar times B, and then plus what? Plus C bar. This is our Y. Okay, that is our Y. Alright, so that is how we can transfer equations into logic gates. I hope you understand. Please drop any comments, or you can actually as well ask any question about this lecture. Otherwise, I wish you well. This is the end.